Hello, my name is Rich Brady, and I am a software engineer with ClearEdge. Today I'm going to do a quick tech talk on Quarkus, which is a technology that you may have heard of recently but might not know anything about since it hasn't really been around for very long. What I'm hoping to achieve with this talk is address what Quarkus is, why does it even exist, and what does it look like in action. Well, if you pull up the front web page of Quarkus, you're immediately presented with some buzzwords. Supersonic subatomic Java. Okay, great, but what exactly does that mean, and how did we get here? I think to properly answer those questions, we need to give things a little context. Let's take a look at the general IT landscape and its evolution over the last few years. It wasn't that long ago that the dominant buzzword in IT was big data. At that time, Hadoop was on the scene. Network latency was a tremendous constraint for moving around large data sets for processing. And so rather than move that data around, in order to compute it efficiently, the data was co-located and processed largely on premise, often many, many times. Fast forward a few years, and we still have large data sets, of course, but now the data is streamed with most processing happening on the fly. Network latency isn't quite the issue that it used to be, and organizations now have flexible storage options with multiple cloud sources to choose from. So today, really the IT landscape has evolved into a world of containers, microservices, and reactive programming. And this is where Kubernetes really comes into play. Basically, a container is the packed application with just the libraries it needs in order to run, and Kubernetes orchestrates and maintains these containers, making sure that they have the resources that they need. So, how is the traditional Java Enterprise application and the JVM working out with the current microservices architecture? Interestingly, one of the Quarkus Red Hat developers, Sanegro Navarro, he gave an excellent presentation at QCon a few months ago, and he provides a few real-world use cases detailing the problems of running JVM applications on the cloud. During his talk, he illustrates some of these drawbacks, including them being cost prohibitive, they don't scale well, and really, you're most likely not going to achieve the higher levels of performance because it takes too long for the JVM in the application to warm up. Uh, Really, I highly recommend watching this presentation on infoq.com. It is free, and he goes much more in depth than the Cliff Notes version that I'm giving here. But Java has its own long and interesting evolution, particularly with context and dependency injection, which you can trace back all the way to the EJB 1.0 spec in 1997. It really wasn't until the last few years when Oracle silently was backing away from Java Enterprise, but luckily other enterprise vendors such as IBM and Red Hat picked it up and started a new initiative, initially released in 2016, called Microprofile. And essentially, Microprofile builds on top of Java Enterprise, but creates new specs and APIs, taking more of a code-first approach. The Microprofile initiative really starts to bridge that gap to microservices and allows you to leverage the underlying Java Enterprise ecosystem and flexibly use their API. By itself, however, it's just still not quite enough when it comes to a complex enterprise application, and hence the need for a framework that will leverage the microprofile API as well as lend itself to Kubernetes orchestration. And for the trivia buff, Quarkus actually emerged from Java's CDI evolution in 2018 as a project called Shamrock and Protean, but then it was renamed to Quarkus in March of last year. With that, it also introduced a new dependency injection implementation called Quarkus Arc, and that incorporates most of the CDI 2.0 spec, but takes things a bit further by offering additional features such as the optional usage of certain annotations such as inject. Which brings us to the high-level view of Quarkus architecture. As you see, there's a Quarkus core component which relies on several optimization tools, and really what that core component does is rewrite the application during the build phase so that it can output a super optimized native executable in Java runnable jars. It's relies on Jandex, which indexes all the runtime annotations, Gizmo, which is a bytecode generation library, and of course it's first class support for Grail VM and Substrate VM. And excuse me, with Quarkus, when you know essentially when an application is compiled down to its native image, it starts much faster and it can run with a much smaller heap than a standard JVM. So as you can see, it's via Quarkus extensions on top of the core component that really provide the gateway to the microprofile API, as well as some of the other familiar faces such as Kafka, Hibernate, and Vertex. Really, to list all the extensions would be pretty exhaustive, and at this point, I think there's over 100 of them. But the point is, it's these extensions that really enable you to continue to use all the best of breed Java libraries and standards. So that brings us back to the beginning, and now I think supersonic and subatomic hopefully make a little bit more sense. Supersonic because of the super fast load times, subatomic because of the very low memory overhead. I think during that InfoQ conference, Mr. Genevero was talking about. He had mentioned that even a small JVM service takes a half a gig of memory. So you multiply that by lots and lots of microservices, and you're talking a lot of dollars. And this is also on Quarkus's website, but it's just an illustration of just how much faster Quarkus is than a traditional stack, both on runtime and on initial boot. Pretty amazing stuff. And let's go ahead and see if we can take a look at things in action. Okay. From a developer standpoint, it's super easy to get Quarkus up and running, and the Quarkus website provides several great examples to get your feet wet. So let's walk through setting up a simple REST endpoint. It'll use JAX-RS, which is simply the Java API for REST services. The great thing here is the prerequisites are minimal and familiar. We're using Java and we're using Maven. The IDE is optional really, but let's use IntelliJ so we can at least get a sense of the project and take a look at it. To get started, this is probably the easiest way to create a Quarkus project, which is via the Maven command. Looks like Maven is happy, so let's go ahead and pull it up in IntelliJ. Okay, so what does this give us out of the box? It's a pretty standard Maven project. You can see your POM file here with lists of dependencies. Obviously, in this case, we have our Quarkus REST easy, so we can actually create our REST endpoint, and it has a couple of testing dependencies. Looks like it's using REST assured for JUnit 5. Also, obviously, in the source folder, you can see we have our greeting resource, which will expose our hello endpoint, and we have a applications property file for the entire project. You just kind of put anything and everything in here that's a property, of course. And it also gives you some Docker file examples for using native and Java builds later on. So let's go ahead and see if we can get this thing going. And it is running. So I'm going to pull up a second terminal and go ahead and try a curl command for the endpoint, and we are good to go. So earlier I had mentioned Quarkus and its Arc dependency injection, which is relatively new, even though it builds on the CDI 2.0 API. But I thought it'd be good just to show real quick the @inject annotation in action here. So what I'm going to do is create a second service class and we will import that into the a modified greeting resource class. And you can see here the at inject annotation. So let's see if we can get this installed. And we'll just replace it with the pre-built. Say view, open up greeting resource, and we're going to take you out and drop in the modified version. Since we're in dev mode, it should pick up the changes we just made on the fly. So let's give it a whirl here. And voila, good to go. So let's go ahead and package this guy and run it as a jar. Come back over here, we'll kill the service. And we can go ahead and simply package it by running the maven w command, package. Okay, so now if you look in the target directory, you can see our brand new snapshot jar, and which is a typical output, but also the runner jar, which we can go ahead and run via the command line. Grab that command, because I can't remember things off the top of my head. And you can see how quickly that started up compared to when we were just running in dev mode. And let's try our services again. Yep, it's working. Also, you can pull this up on the browser. Let's do that here, if you want to do it that way. And everything looks like it's running. Obviously, that was a very simple REST microservice we created in Quarkus, but hopefully it gives you a sense of how easy the framework is to work with. I definitely encourage you to walk through the rest of the examples on the Quarkus site. They really get into building the native image, as well as working with more of a reactive, some of the reactive APIs like Postgres, and there's just so many. But at any rate, I think I am already run past my time limit, so I'm going to cut it here. I really appreciate you listening. Thank you.